Hello, my name is Schatten. I'm talking with Stefan Biffl today, who is the head of the new Doppler lab for software engineering integration for flexible automation systems. Sounds quite complicated. Maybe you can give us a brief introduction about yourself.
Yes, my name is Stefan Biffl, and I'm the head of the new Doppler laboratory for software engineering integration for flexible automation systems. I'm located at the Vienna University of Technology, and I'm a member of the Faculty of Informatics. My background is software engineering.
Maybe we could give a very brief introduction what the purpose of this lab is.
Yes, in one sentence, the purpose of the Doppler lab is to provide a software platform to improve the engineering of flexible automation systems. And the purpose is necessary because the current software tools of the engineering disciplines involved in automation systems engineering are not well integrated, and therefore many defects occur and the projects take longer than they should.
Now we mentioned the term Doppler lab several times. Maybe you can give a short overview what a Doppler lab usually means, or what does it mean in our specific case?
A Doppler laboratory is application-oriented basic research funded by the Doppler Research Society, and the good thing about this lab is that it runs over up to 7 years. So it's a long-running funding.
And industrial partners are part of the lab, or?
Yes, we have several partners, and it's important also to mention the research partners. We have researchers from 2 faculties, informatics and electrical engineering, and we have also 2 industry partners. One is the company Logicals, and the other is the company Certicon.
And our research partners are partly at Vienna University and partly at University in Prague.
Yeah, well, in addition to the researchers employed in the laboratory, we have also a good number of associated researchers, and they're also in the Technical University of Vienna, at Secure Business Austria, and also at the Technical University of Prague.
Now, what would you describe as the main research challenges of this laboratory?
Well, here, if you look at this slide, you see a very rough process of producing an automation system, for example, a hydropower plant or an industrial automation system for making cars. And what you see here is the different steps in the process and the different engineering disciplines involved in making this production happen. And in theory, this is a sequential process, meaning that you can make one step after the other until you are finished. But in reality, it is a more iterative process because the iterations are necessary as new requirements come up during the project, or you find out that the design does not work exactly like you planned.
So you want to have a more iterative step, and the step from one engineering discipline to the next is problematic in the current situation.
Yes, because the engineering disciplines use different software tools. These software tools are not well integrated. And therefore manual steps are necessary for this achieving the integration between the engineering disciplines, and this means that you have delays and risks of defects coming into the process.
Now, what are the specific challenges in integrating different engineering environments? Maybe you can talk a few words about that.
Yeah, so the goal is to integrate software tools from different engineering disciplines, and you have to address 2 levels of integration. One is the so-called technical integration, where you integrate the tools that use different technical platforms so they can exchange messages and basically talk to each other. You can see here the current state of so-called accidental engineering environment integration, and you see here 3 organizational units who work together in a
like
project.
A main contractor. What does EPC contractor mean?
Yes, exactly. And the problem here is that the different software tools represented as colored boxes and documents and databases are integrated accidentally, meaning it was not planned from the start. It's not a systematic integration, and you have a lot of problems coming from this. For example, if this system gets complex over time, you lose oversight. So the goal is in technical integration to have a more systematic integration for iterative engineering. And what you see here on the right side is we plan the so-called software platform automation service bus. The automation service bus helps in one organizational unit, for example here the main contractor, to provide connectors and a neutral platform between software tools so they can exchange messages with each other. And also it's possible, if you have several organizational units involved, to install an automation service bus at all facilities, so you have a comprehensive systematic integration.
But it's also important, so you actually also can control what sort of information is exchanged between the partners. It's not like all information that you produce within your organization has to be open to your partners, but you can have a sort of a selective.
Yes, it's very important. In modern distributed engineering, you want to make sure that all partners have access to the information they need for their work, but not more.
Exactly. Now, what are the concrete benefits that an industrial partner could expect from participating in this research lab?
Well, we said there are two integration challenges. The second integration challenge is the so-called semantic integration challenge, meaning that once the tools can work together because of technical integration, you find out that the data models in different engineering disciplines are different. And that means you need to integrate also the data models, and you can see here on this slide as ellipses the data models of the different engineering disciplines in colored ellipses, and they have an overlap of so-called common concepts that they need so they can work together to produce an automation system. They have to be able to talk to each other and exchange information. And therefore we focus on the overlap of data models between engineering disciplines, and here we have achieved an approach for semantic integration. And once you have technical integration and also the layer of semantic integration, the major new benefit is that you can find defects in the engineering process and data models across software tools from different engineering disciplines. And this kind of defects you cannot find in any one tools. So it was not possible to find them automated before. And therefore it's a lot of manual work, and often these defects go through into the system, which is a risk for operation and also costly to remove these defects later.
So for industrial partner, after having integrated the technical level and semantic level, the advantage is to have an overall view of the engineering process, ideally end-to-end, and the advantages. The
core advantages are to find the defects early, before they produce problems. And the second is you can observe the whole engineering process and automate major parts of the engineering process, which makes the process more efficient. And also you can shorten the duration of engineering projects.
Okay.
In order to provide the benefits to industry partners, it's important that we require use cases coming from industry partners. So we work with domain experts at the industry partner to see what are the concrete issues in the context. And the second thing is we provide the research prototypes that address these challenges, and we need domain experts at the industry partners who validate our research prototypes to increase research, but also to provide immediate benefits for the research partner.
Okay, thank you very much for the talk.
Thank you.